All right, so relationship between inverse functions. It says we can show that if G is the inverse function of f, then f of g of x is equal to x. Similarly, if f is the inverse of g, then g of f of x is equal to x. So in other words, what they're saying is that f of f inverse of x is equal to x. And I'm thinking that f inverse of f of x is equal to x. So that's what they're saying. Now, let's have a look at example 34. It says, let f of x be equal to 2x plus 1. We're to find f inverse of x. So let's do that. F of x is equal to 2x plus 1. Well, at this stage, which is at the pure mux level, you should be able to say that f inverse of x is actually equal to x minus 1 over 2. That's what you should be able to say. But if we're going the long way, which is to go through the 4 steps, it would be y is equal to 2x plus 1. This is step 1, which is to write the defining equation. Then 2, x is equal to 2y plus 1, which is that's step 2, which is to interchange x and y. Step 3, x minus 1 is equal to 2y. Divide both sides by 2. And we get that y is equal to x minus 1 over 2. Step 3 is to make y the subject again. And step 4, take out y and say f inverse of x is equal to x minus 1 over 2. So the next thing we need to now find is we need to find f of f inverse of x. Now, f of f inverse of x is a composite function in which the range of f of x is the domain of f. In other words, in f, wherever I see x, I'm going to put f inverse, which is x minus 1 over 2 plus 1. Simplifying, the 2's cancel. We're left with x minus 1 plus 1. Now, minus 1 plus 1 is 0, so we're left with just x. So f of f inverse of x is equal to x. So in example 35, we're asked to find the inverse of f of x is equal to x plus 1 over x minus 2. Step 1, replace f of x with y. So this is y is equal to x plus 1 over x minus 2 is the defining equation. Step 2 is to interchange x and y. Wherever you see x, put y. Wherever you see y, put x. Step 3 is to make y the subject. So let's get rid of the fractions by cross multiplying. Remove the brackets by applying distributive law. Let's get all x's to one side. Sorry, all y's to one side. And all x's to the other side. Over the left, I'm going to factor out a y. and this is equal to 2x plus 1. Then I'm going to divide both sides by x minus 1. And I'm going to end up with y is equal to 2x plus 1 over x minus 1. Now, y is equal to 2x plus 1 over x minus 1 is the defining equation for f inverse of x. Next thing we need to find, f of f inverse. So we need to find f of f inverse. So in f, wherever I see x, I'm going to replace x with f inverse. So that is going to be 2x plus 1 over x minus 1 plus 1 all over, sorry, it's supposed to be, all over 2x plus 1 over x minus 2 minus 2. Let's simplify this. We have what? 2x plus 1. Now, if the theory is correct, the final answer for this is supposed to be x. So this is the numerator. Divide by the denominator. Minus 2. Let's make the numerator into one fraction. We have 2x plus 1 plus x minus 1. Divide by, let's make the denominator into one fraction. All right. Let's see if we made a mistake somewhere. I think I did. There's supposed to be a 1 here. And here as well. It's supposed to be a 1. So 1 here, 1 here, 1 here. We have 2x plus 1 minus 2, sorry. 2 into x minus 1. Up top, we have 3x over x minus 1. That's the numerator. Divide by 2x plus 1 minus 2x. And this is plus 2 all over x minus 1. This becomes 3x over x minus 1. Let's change this to multiply. Multiply by invert x minus 1 at the top. And down by the bottom, we're going to have 2x minus 2x is 0. 1 plus 2 is 3. So this cancels that. 3 cancels 3. And we're left with only x. So f of f inverse of x is equal to x.